Greetings Internet, Sean Shooping here. Welcome to part 4 in my Over-Engineering Your Home Lab series. In today's experiment, I'm going to be breaking things intentionally to see how fault tolerant my lab really is. And then staying true to the deploy cattle, not pets methodology, I'm going to be replacing broken units at the end instead of fixing them to bring the lab back to a healthy state. So the formula for today's experiment is pretty straightforward, but before I go ahead and break stuff, I think it would be beneficial for me to show how all the infrastructure and services are logically laid out in the environment. So in the lab, I have 6 availability zones and 4 service layers. The availability zones are simply where the workload runs. In this case, this is the physical machine that hosts the VMs or app. The service layers are groups of applications which make the solution work as a whole. And in my case, the 4 service layers are the automation layer, the proxy or load balancing layer, the MAS/orchestration layer, and the database layer. So failures can either occur in the service layer itself or at the availability zone. To ensure availability of the solution as a whole, it's a good idea to have multiple workers in each service layer and then span those service layers across multiple availability zones. So to get started, I want to kill off one of the Juju controllers to see if that impacts the automation layer. And then I want to see if we can actually deploy resources while the automation layer is in the degraded state. Actually, I have a better idea. Let's kill off one of the physical servers which actually hosts one of the Juju controllers. Now, I don't actually know which machine this is because they come up randomly. But what this should do is that there's a Juju controller on here and there's also a load balancer on here. So that's actually going to create a outage in both the automation service layer as well as the load balancing layer. So if we switch to the Juju CLI, we can still switch between models and get the status of things. And here we can actually see that one of the Juju machines is down. But this kind of proves that the Juju/automation layer is still working because we can actually get these status outputs. If we switch to one of the load balancers and check the cluster status, we see that one node is down, but that service layer is still fine because we can actually still use the MAS GUI through the load balancer. If we want, we can actually deploy new resources using Juju, which uses the load balancer. And here we can see that both layers are perfectly fine, even though they may be in degraded state. Okay, so moving further down in the stack, let's actually add to the list of broken things in the lab. So what I'm going to do is that I'm actually going to kill one of the MAS controllers, and one of the MAS controllers actually sits up here, and that's actually the primary MAS controller. So let's do a similar thing. And by the way, I don't recommend doing this.
12 seconds later.
Frick is actually going on here. Oh, joy. Whee.
Later.
Okay, so I was expecting there would be no impact here, but clearly there is. I know exactly what happened here. The whole lab is actually configured with one DNS server because when I initially deployed everything, I only had one MAS server and then I added the second one later on. So before I deployed anything, what I should have done is made sure that each subnet managed by MAS has the IPs of both MAS servers in the DNS config. After I rebooted my machine, I picked up both DNS servers and my internet came back. But I needed to manually edit etcresolve.conf on all the deployed CentOS machines and fix netplan on all the Ubuntu machines, because Cloud Init didn't update the network configuration despite it saying in the config files that it does. Okay, so that said, after I fixed all of my stupid problems, I'm still a MAS controller down, as you can see, but I actually still have a fully functional core infrastructure, so that's actually pretty cool. What happens if we create a failure at the database layer? Now, spoiler alert, I know what's going to happen here, and this is kind of the elephant in the room because it goes against everything that I've been saying throughout the series. I don't want to have to go manually failover into the standby component of whatever's broken. So that said, I'm kind of okay with this because it's a massive improvement from my old ways, and I won't have to rebuild everything because I technically have a replica of all the data in that database. So when the live database fails, MAS obviously has no backend data storage, but things like DHCP requests and DNS requests still seem to work fine but the MAS GUI is completely inaccessible. You're kind of lights out and flying blind if you don't know the names and IP addresses of things managed by MAS. So initially I thought I would be able to run an action called switch to promote the slave database to live master, but that was a bad assumption because it just sits there waiting for permission from the master server to switch over. Now obviously this is dumb if the master is gone for good. What I needed to do was instruct Juju to remove the dead unit from the model, which then promotes the slave to master. This was kind of scary because at first it didn't appear to be doing anything, and I didn't know if I would be able to get the database out of read only, but eventually it forcefully promotes the slave to master. After that, I can reconfigure MAS to point to the new live database by editing the regiond.conf file and point it to Postgres-1. And then after that, simply run a snap restart MAS. Once MAS becomes available again, Juju is actually able to release the broken Postgres machine off the model. And the release machine can now be considered a brand new machine because it's no longer deployed, it's in the ready state. And any data that was sitting on that virtual hard drive is now gone. So at this stage in breaking stuff, I'm kind of like 3 components down. I've got like a MAS server down, I've got a hypervisor down, and I've got a Postgres database down. But I actually still have a functioning lab, which is kind of cool. Now we can actually get to fixing and re-provisioning all the broken resources. To re-protect the database, I can simply run a juju add-unit PostgreSQL to Postgres-0, and that's the machine that got released back into the MAS pool. That's going to reinstall that machine and then eventually clone all the databases once Juju finishes installing and configuring Postgres. To bring the Juju cluster back to a healthy state, we can get rid of the dead unit on the controller model by running a juju remove machine number 3 -- force. We can then replace it by composing a new machine in MAS and attaching a Juju tag. After that, I'll simply run a juju enable -ha again. That's going to send a request to MAS for a new machine. And here we can see that MAS starts installing a machine matching the bootstrap constraints when we created the Juju controller. I actually had a bit of fun with replacing the dead unit in the load balancer. I've composed and deployed a 4th CentOS machine called Load Balancer 3. And just like when I built the load balancer cluster, I'll use Ansible to replace the failed node with a new one. I'm going to run the playbook on Ansible AWX because I can use something called a survey on the task template. When I launch the playbook, it will ask me questions about what I'm trying to do, and it will use my answers as variables in the play. So if we look at the code real quick, it's pretty similar to the playbook that I used to build the load balancer cluster, but these 2 variables aren't actually declared in the code. They'll be provided as extra variables provided by the survey. If we look at what I'm actually doing, I'm forcefully removing an old cluster member with a PCS cluster node remove old node name answer variable, and then authenticating and adding new cluster nodes with the new node name answer variable from the survey. What I'll also need to do is remove the old node from the load balancer inventory and add the new one so that tasks which install and configure required packages are executed on the new vanilla node. After the task completes successfully, we can check the PCS cluster status again. And here we can see that the offline cluster member load balancer 1 has been replaced with our new machine load balancer 3. And just like that, that brings my core infrastructure back to a healthy and happy state. And that actually brings me to the end of this series. Now that doesn't mean that this is the last you'll be seeing of the lab, but I can actually finally get to use the lab for what it was intended for. If you've made it this far in the series, thank you for watching. But that's pretty much all I have for this experiment. But I will see you in the next one. Peace.